Okay, now we're going to get to something that's a little more difficult. This is going to be find d squared y dx squared. So in other words, what we want to do is find dy dx, and then we want to differentiate again. So the second derivative. Let's see how we do that. Well, the first thing that we're going to do is, like we always do, take the derivative with respect to x of both sides. Okay? So what's the derivative of x squared? That's 2x. What's the derivative of y squared? Again, this is chain rule, right? So it's 2y, y prime. What's the derivative of 25? That would be 0, right? We're going to still solve for y prime. So that's our first thing we're doing, is solving for y prime. So what I'm going to do is I'm going to subtract off 2x from both sides. And I would have 2y, y prime equals negative 2x. I'm going to divide both sides by 2y. Notice those 2's are going to simplify. And I'm going to have y prime equals negative x over y. Okay, now what do I do that I have this part? Now I want to do the derivative again. So I'm going to do this in, let's say, green. So I want to take the derivative with respect to x again of both sides. So when I take the derivative with respect to x, well, the derivative of y prime would be the second derivative, y double prime, which is what we're looking for, right? And on the right-hand side, now I need to use the quotient rule. So I'm just going to keep the negative out in front. It's like a -1 constant multiple, right? And I'm going to do low, which is y, times the derivative of the high, which would be 1, minus the high, which would be x, times the derivative of the low, which would be y prime, right? All over the bottom squared, which is y squared. Okay, so what's the key to this now? The key to this now is I have to substitute in for y prime into this equation. Y prime is negative x over y. So let's go ahead and plug that in. This would be y double prime is going to equal negative. Well, 1 times y is just y. And then it's minus x times y prime. We know y prime is negative x over y. This is all over y squared. Okay, this is a compound fraction. Again, we're going to multiply everything by the denominator. In this case, we're multiplying everything times a y on top and on bottom. And when I do that, I'm getting y prime equals negative. Well, I'd have y squared. Notice these y's would go away. Negative x times negative x would be plus x squared. And then y squared times y would be y cubed. So that would be our answer right there. We have a negative y squared plus x squared over y cubed. But the book goes even further than that. It goes back and it looks at the original problem. The original problem, let me do some highlighting here. X squared plus y squared equals 25. And it swaps in that x squared plus y squared equals 25. So they say, or you could say it's equal to negative 25 over y cubed. So I'm just going to leave my answer like this, because this is honestly how I would have left it in class. Negative, and then it's a y squared plus x squared all over y cubed. Again, you could do that back substitution, the 25 for the x squared plus y squared, but I wouldn't have expected you to do that part. Okay, let's continue on to example 8. It says, find the tangent line to the graph of x squared times the quantity x squared plus y squared equals y squared at the point square root 2 over 2, square root 2 over 2. So let's go ahead and give this one a try here. Let's see what we got going. Again, anytime you have these equations, the first thing you're going to want to do is take the derivative with respect to x of both sides of these equations. And on this first one, actually, let me go ahead and take a step back. I think what I want to do is a little bit of simplification on that left-hand side. Specifically, what I'm talking about is I'm going to go ahead, because I don't want to have to do the product rule, is really what it comes down to. So I'm going to multiply both of these terms times x squared. I'm going to distribute that out. So what my equation really is, I'm going to get x squared times x squared is x to the 4th, plus x squared times y squared is x squared y squared, equals on the right-hand side I have y squared Sorry, it looks like the square didn't come through there. So it's x to the fourth plus x squared y squared equals y squared. Now I want to differentiate both sides with respect to x. And when I do that, let's see what we get. What's the derivative of x to the fourth? Well, the derivative of x to the fourth is 4x cubed. X squared, y squared, again, we do have a product rule there. So it's going to be the first, which is x squared, times the derivative of y squared, which would be 2y, y prime, plus the second, which is y squared, times the derivative of first, well, the derivative of x squared is 2x. And then on the right-hand side, again, we have the derivative of y squared. Using that chain rule is 2y, y prime. So let's get everything with a y prime on one side, everything else on another, and clean some things up here. So I'm going to subtract off a 2xy squared from both sides. I'm also going to subtract off a 4x cubed from both sides. I'm going to subtract off a 2y, y prime from both sides. Okay, so when I do that, let me get rid of all the terms that I just got rid of. Let's see what we have left. That should get everything with a y prime on the left, which would be a minus 2y, y prime. And then we have what? Plus x, 2xy. Sorry, let me go back. It's a 2x squared y, y prime. And then everything else canceled. On the right, I should have a minus 2xy squared and a minus 4x cubed. Let's keep on going. We know that we isolated y prime because we want to factor out a y prime of everything on the left. So if I factor out a y prime on the left, I would have a minus 2y in the first term and a plus 2x squared y in the second term. Remember, on the right, we still have minus 2xy squared minus 4x cubed. We're going to divide both sides by everything that's next to y prime, which is negative 2y plus 2x squared y. Again, both sides divided by negative 2y plus 2x squared y. And when we do that, we end up with y prime equals negative 2xy squared minus 4x cubed all over negative 2y plus 2x squared y. Can we do some simplification? I'm sure we can. Like, for instance, on bottom, I see we can factor out a new negative 2y. On top, I see we can factor out a negative 2x. But look at the problem. Does that matter when it comes to the problem? The problem doesn't say simplify your derivative. The problem says find the equation of the tangent line. All we're doing right now is just finding the slope. We already know what the point is, right? The point is given to us, so we need the slope at that point. We're not even finding the equation of the line yet. So what I'm going to do is I'm going to plug in my x and y values here. So we're going to look at it at x equals root 2 over 2 and y equals root 2 over 2. Again, I'm not saying this is pretty. We're going to plug it into our calculator, but let's give it a go. We would have y prime equals negative 2 times, we'd have root 2 over 2 times root 2 over 2 squared minus 4 times root 2 over 2 cubed all over negative 2 times root 2 over 2 plus 2 times root 2 over 2 squared times root 2 over 2. That is an absolute mess, but that's okay. I want you to go ahead and plug that into your calculator and tell me what you're getting. I'll give you a moment now. When I did this, believe it or not, I know it's a mess, I ended up getting the number 3. So it ends up being a nice slope value. That's our slope that we're going to use, right? So we have our slope, we have our point. So what do we do now? We do step 3, which is y minus y1 equals m times x minus x1. So in this case, we would have y minus the y values, root 2 over 2, equals m, which would be 3, times x minus the x value, which is also root 2 over 2. I'm going to distribute the 3 times the x and the 3 times the root 2 over 2. So I have y minus root 2 over 2 equals 3 times x is 3x, and then 3 times root 2 over 2 is minus 3 root 2 over 2. I add a root 2 over 2 to both sides. and I end up with y equals 3x, and then that would be 2 root 2, negative 2 root 2 over 2, and the 2's would simplify, so that would be just a negative square root 2. So there's my final answer there. Y equals 3x minus the square root of 2 would be the equation of the tangent line of that graph, the graph of that equation, at that given point. An absolute mess, but that's what it is.